All right, our next presentation is by Rory Macneil from Research Space, Terrell Russell of the iRODS Consortium, and John Martin of University of North Carolina at Chapel Hill. And their talk is entitled, A Team Approach to Enabling Streamlined Generation, Aggregation, Management, and Reuse of Primary Data.
So I'm not going to say very much for this talk, but I did want to say I approve this message. This is something that we're working on together, and we hope to do first here at UNC and then potentially other places depending on how it goes. We've written no code yet, but it's coming.
Okay, thanks, Terrell. I'm Rory. So just an outline of what we're going to cover in the talk. We're going to talk about some existing bottlenecks to efficiently making data fair. We're going to talk about RDM as a team sport. This is one of my favorite topics. So I'll just say a little editorial comment here. I think that all too often developers of tools and funders of tools, all they think about is their own tool. And so their head is in the sand making their tool better. And I think that's the wrong approach. I think we need to think about tool interoperability from the start and think about workflows. And it's almost always going to be the case that to support workflows, we need multiple tools involved. And so from the early stages, the tools should be thinking about how they can work together, develop together, interoperate. And why do we do this? It's the only way to produce scalable and generalizable solutions. And how do we do it? By leveraging the strengths of each tool, because they're all different. And our team that we're going to talk about today is Team iRODS, RSpace, and Dataverse. And then we're going to talk a little bit about the opportunities that Terrell referred to, which we haven't written any code for yet. So let's get started. So I think we would probably all agree that research data management at the moment is not concerted. You've got tools like electronic lab notebooks, you've got data repositories, you've got data management plans. You have, we don't have that many, but you have iRODS, which is probably could be used, should be used more widely and more widely in conjunction with other kinds of tools, but currently they're not. And that's bad because it makes it very difficult for fair data to be implemented. It makes it difficult for data and metadata to flow seamlessly throughout the research data lifecycle. Now I'm going to pass over to John.
So I'm John Martin. I'm the I direct data architecture and infrastructure at the UNC Research Data Management Core, which is a fairly new group at UNC in the research division. And what I put up here is just a very brief sort of categorical grouping of what I'm aware of or own currently at UNC. And I want to use this as a moment to illustrate the problem space. And we did basically a one-to-one replacement with the word problem and opportunity later in this presentation. But I come to this with the problem space, and I also come with a group that has long experience doing data archiving and sharing using Dataverse as our central repository software, which we're now starting to leverage at UNC to also provide something more like a unified data catalog. So we're going to have pointers out to other archival locations. But right now, this is what this looks like for us. We have a whole bunch of different systems that people are using for different things, some of which we own together. So we don't. There are no barriers to integrating this aside from doing it. And really, the opportunities aren't there. They're obvious next steps in some cases. But this is the state of things right now, and this is just what I'm aware of. Every day I become more, sort of more aware of the space. And I learn a new thing that hasn't yet been integrated. What we're envisioning here, and this is very hand-wavy and intentionally so, I don't want to impose too much yet because we have several brilliant teams of people who I want to chew through this problem space. So, but what I see is something that's a little bit maybe different than what any of these tools has done previously, but also is resonant with the direction that they all seem to be going. RSpace to me has always seemed like a data orchestrator. there's something about it that they've been very intentional about integrating and allowing for integration and having a robust API framework. And I feel like this is a great opportunity to put it right smack in the center of this whole ecosystem. Dataverse, again, it has a built-in catalog. It's very good at this. It's very good at storing long-term archival data, storing and sharing that data. And iRODS also it feels to me like an orchestration layer or a common messaging framework or something along those lines that we can actually use as glue between a lot of this. We're also dealing with a lot of legacy data systems, so that's another bag of cats that we don't really need to get into, but that ultimately provides the source data for metadata for what becomes project data later. And so I'll hand it back to Rory, and then I'll come back in a minute to talk about opportunities here.
Thanks, John. So I guess we're going to take that was kind of a very big picture of what the problem and how we want to address it. Let me now take it still pretty high level, but take it a little bit deeper. So our vision, another way of thinking about what John just described is thinking about a little bit more in terms of a workflow or research data lifecycle approach. And that is, so concerted research data management starting from creation to active use to preservation and publication. So again, the three tools are RSpace, which has an ELN. It's not really an ELN because it's a lot more than that, but it has an ELN, iRODS, and Dataverse, so you can bring in the context, scientific record, provenance through RSpace, then the data management, active HPC orchestration, storage automation, all the stuff which you guys know a lot more about than I do with iRODS, and then the benefits of a very good repository, which is, I think, arguably the most dynamic of the generalist repositories because of the great community that Dataverse has in terms of the ability to curate and through association with PIDs and ontologies enable discovery. So that's kind of our vision, if you will. So the team, again, is iRODS, Dataverse, and RSpace, and everyone here is very familiar with iRODS. iRODS needs no introduction. I looked for a graphic for Dataverse, and unfortunately I couldn't find one, a very good one. But I think you're all familiar with, some of you are very familiar with Dataverse, and probably all of you are familiar with the general concept of a generalist data repository. And some of you are familiar with RSpace, but for those who aren't, just very briefly, if you look at the graphic on the right, so if you look at the center, RSpace started out as an electronic lab notebook. Electronic lab notebooks now have become kind of commodified. So that's just, you just kind of take for granted, okay, that's there. Then we added on a very sophisticated, modern, nice sample management system. So you now have the ability to associate physical samples, data around physical samples with the experimental data. And then we have, as you can see, a whole ecosystem of integrations, and really the ecosystem has overcome the tool. And I think it's fair to say in some ways that's kind of the inspiration for our vision more generally with RSpace and Dataverse, this integrated approach. So if you look at the purple things, those ones are data management planning tools and repositories. And we have integrations which allow data to flow between them. So that's kind of the research data management aspect of the ecosystem. And then the stuff in blue includes data storage as well. And then includes more specialist things which different domains would use, things like Omiro for bioimaging, and other ones which I won't go into details. But again, they're kind of the research part of the workflow. So one way you could think about RSpace is where research meets research data management. That's another way to think about it. So then just two more slides, and then I'll pass back to John, who's going to tell you about some of the things that we are thinking about actually implementing. So this one is kind of a tool-oriented perspective of what we're doing, and the next one is going to be a bit more of a research data lifecycle workflow perspective. But again, if you look at RSpace, some of the things that RSpace can do is help with field studies, taking in samples and data and metadata, whether actually it's in the field or in the lab, data from instruments, and then taking this data and putting it in associating with other data from external resources and allowing you to provide a good picture of the experimental context. And then again, iRODS, which everyone here knows more about than I do, the kinds of things that it can do with data exchange with computational resources, workflow metadata and provenance, and validation and verification. And then again, Dataverse, where it kind of, the data, not for the long-term storage purposes, but for the sharing and reusability purposes, it becomes a verified resource where people can discover and look to reuse and reproduce. And this really is saying the same thing, this slide, but with a slightly more, again, chronological perspective, if you will, as opposed to a tool-oriented perspective. So you could imagine at the beginning, the active data phase, you have the researcher working in our space with their experimental data, with their samples, providing experimental context, and then going through association, better association with data that's stored, with metadata through iRODS, and then a curation phase where you come in with Dataverse. And that's that, and I'm going to pass back to John.
We can make this part quick. So this is effectively a listing of opportunities that we see here, and these will in some form become targets for this project, whatever shape it ends up taking long term. So we have a path from our space to Dataverse. That's known, that's built in. What I've approached Rory and Terrell with is the idea that I would really like to see a path back the other way. Like I would like for logged in personnel at UNC to be able to look at data in Dataverse and then actually provide them a reuse path instead of providing the reuse path of export this data, this enormous data set, download it, put it on a laptop somewhere, put it somewhere else, then do whatever you're going to do with it. No, I want to provide them a way to just, and I mean, like it's dumb, but I think of it as like a button, right? Like I just want a silly button that says reuse this data and then it dumps it into wherever you need it to go, right? That seems simple. It's not simple, but we already have the path one way. So the path back seems maybe a little bit obvious to me. We do need some metadata interoperability framework. These systems do not talk to one another by design. And this is what Rory's aiming at, is that we don't necessarily develop our systems in concert with one another. I also have the not unique problem of we manage both self-hosted open source software. We develop some software in-house. We use licensed software that we have running on our on-prem equipment. We have licensed software that we have running on cloud environments. We have vended software that is cloud-based that we don't own the cloud. We have multiple clouds involved. So something that this is not a unique situation. We need a way for the metadata that's being produced at each stage in the research data lifecycle to actually be concordant, both with the metadata needs at the end of the process and also at the beginning, which is sort of project startup data, administrative data. Sync across systems that need to sync is another obvious thing, but having a standardized way for the APIs to interact with one another is important here, and I think that this will be kind of the primary glue of what we're doing. And then this is the part that Terrell says is hard, and I take that, I agree, and this is where I think I know the least, which is that we need a common messaging framework, right? Basically, we need a way for all of these things to actually talk to one another, not at an operational level, but at an awareness observability level as well. This is what will ultimately provide us the ability to do kind of high-level orchestration and administration across these systems and have them interoperate as an ecosystem rather than as atomized parts, disintegrated parts. So that's super fast. And Rory, I think maybe you wanna take this last bit and can.
1 minute. Okay. Yeah. So I think we're already talking with iRODS. So just want to kind of throw this out. It seems to me that Yoda and Mango are the two kind of sub-communities that have developed in iRODS, just observing the UGMs the last few years and listening to the presentations. So again, there should be opportunities, we hope, not to do this work in in isolation from the Yoda and Mango communities, but to actually work together. So that's really the theme of this slide. And just a point to note is that research base is actually part of Yoda's OSNL proposal as well. So that gives us a little chink of something to work together, but I think there are other bigger opportunities for us to work together. And I don't think we really have time to go into this, but I think the message is we'd be happy to explore with Yoda and Mango communities about ways in which we can work together as we go forward in this project. And I bet you that was under 1 minute, Terrell?
Under 1 minute? Yeah. I will say that our main goal would be to develop no software. Yes. But we haven't convinced ourselves that's possible yet, so help.
Help us not do that.
All right. All right. Thank you.